Look at your face in the mirror. The shape of your brow, the angle of your chin, the structure of your skull beneath the skin. For most people alive today, what you are looking at is not purely human, not in the way we once thought. We are composites, mixtures, blends of lineages that were once separate and are now joined forever. The face in your mirror tells a story of ancient encounters. Somewhere between 1 and 4% of your DNA came from someone who was not Homo sapiens. From a species we once considered brutish, primitive, inferior, from the Neanderthals. They are inside you right now, reading these words through eyes they helped shape. 35,000 years ago, give or take a few millennia, two human species shared the same valleys, the same forests, the same caves of Ice Age Europe. Our ancestors and their cousins, living side by side in a world we can barely imagine. It was a world of mammoths and cave lions, of glaciers that reached from Scandinavia to Germany, of winters that lasted most of the year and summers that were brief and precious. A harsh world, but one that two species of humans both called home. If you are watching this to fall asleep tonight, that is perfect. This mystery has been waiting 35,000 years. It will still be here when you wake up. Subscribe and stick around. Let us explore what happened when two kinds of humans met. We need to start with what Neanderthals actually were. Forget everything you think you know. The image of the hunched, grunting caveman is wrong. Spectacularly, embarrassingly wrong. It says more about our prejudices than about them. The first Neanderthal skeleton was found in 1856 in Germany's Neander Valley. Scientists of the time could not believe what they were seeing. Some argued it was just a deformed human. Others thought it might be an extinct ape. The reconstructions they made reflected their assumptions: stooped posture, brutish features, vacant expressions. They created the caveman stereotype that still haunts popular imagination today. Modern science tells a different story. Neanderthals walked upright just as we do. Their posture was human, their gait was human. They were not the shambling apes of old illustrations. Neanderthals had brains as large as ours. Often larger, their skulls held more neural tissue than modern human skulls typically do. Whatever they lacked, it was not raw cognitive capacity. Their skulls were differently shaped than ours, longer from front to back, with a more prominent brow ridge. But the volume inside was impressive. They had the hardware for complex thought. Whatever their software may have been, they made sophisticated tools. Not just crude hand axes, but carefully crafted blades, scrapers, and points. The Levalar technique they used required planning several steps ahead. You had to envision the final tool before you began shaping the stone. They hafted stone tips onto wooden spears with adhesives. They manufactured from birch bark. This process required heating the bark to exact temperatures, collecting the pitch, and applying it before it cooled. Chemistry and fine motor control combined. Their hunting weapons were effective. Analysis of Neanderthal spear points shows they were used for thrusting, not throwing. They hunted large game at close range, a dangerous strategy requiring courage and skill. The injuries recorded in their bones tell the story. Healed fractures consistent with close combat with large animals. These were people who faced mammoths and woolly rhinoceroses at arm's length. They buried their dead. Graves have been found with bodies arranged carefully, sometimes with objects placed beside them. At Shanidar Cave in Iraq, flower pollen was found near a burial. Were the dead laid to rest with flowers? The flower burial interpretation is controversial. The pollen might have been carried by rodents, but other graves show clear intentionality. Bodies positioned, stones placed, spaces prepared. Something was being expressed. Whether this indicates belief in an afterlife, we cannot know, but it indicates something beyond mere animal behavior. It suggests that Neanderthal lives had meaning to other Neanderthals, that their deaths mattered. They cared for their sick and injured. Skeletal remains show individuals who survived serious injuries and disabilities for years. Someone fed them, someone protected them, someone thought their lives had value beyond their utility. One famous skeleton from Shanidar Cave shows a man who had lost the use of one arm, probably from birth. He also suffered damage to one eye and one ear. Yet he lived to old age. His group kept him alive despite his disabilities. Another skeleton shows healed injuries that would have been completely debilitating without help. A broken leg, damaged ribs. This person could not have hunted or gathered for months. Someone else provided food while they recovered. This kind of care is not automatic. It requires choosing to share resources with someone who cannot contribute. It requires seeing value in individuals beyond their productivity. It requires something we might call compassion. They made art. This was controversial for decades, but the evidence is now strong. Painted caves in Spain date to before modern humans arrived in the region. The artists had to be Neanderthals. There was no one else there. The cave paintings in Spain are remarkable. Red hand stencils, abstract shapes, geometric patterns, dating techniques place them at over 65,000 years old. Modern humans had not reached Europe yet. The artists were Neanderthals. They wore jewelry. Eagle talons strung as pendants, shells collected far from any shore, feathers from birds of prey arranged decoratively. They cared about how they looked. They adorned themselves. Collecting eagle talons required hunting one of the most dangerous birds in Europe. Eagles do not give up their talons easily. Someone risked serious injury to obtain decorative items. Appearance mattered enough to take risks. The shells found at Neanderthal sites came from coastlines, sometimes over 100 kilometers away. Either Neanderthals traveled that far, or they traded with groups who did. Both explanations suggest complex social organization. They used pigments. Red ochre and manganese dioxide have been found at Neanderthal sites, sometimes worked into crayons. Were they decorating their bodies, their possessions, their living spaces? We can only guess. They controlled fire. They cooked their food. Analysis of dental plaque from Neanderthal teeth shows they ate cooked vegetables alongside meat. They were not the pure carnivores we once imagined. They likely had language, though we cannot know what it sounded like. The anatomy of their throats suggests they could produce a range of sounds similar to ours. Their brains were wired for speech, or something like it. The FOXP2 gene, associated with language in modern humans, was present in Neanderthals in the same form. Whatever genetic machinery we use for speech, they had it too. In short, they were people. Different from us, certainly, but people nonetheless, thinking, feeling, creating beings who lived on this planet for over 300,000 years before we arrived. And then we did arrive. Modern humans, Homo sapiens, expanding out of Africa, we reached Europe around 45,000 years ago, and for roughly 10,000 years after that, both species shared the continent. The migration was not a single wave. Modern humans entered Europe in pulses, retreated during harsh climate periods, and advanced again when conditions improved. The ebb and flow continued for millennia. Think about that time span, 10,000 years of coexistence. That is longer than all of recorded human history. Longer than the time from the agricultural revolution to the present day. Generation after generation living alongside each other, 400 generations. Roughly 400 opportunities for conflict, for exchange, for the full range of human interaction. Not a brief encounter, but a long, complex relationship. What happened during those millennia? Did the two species fight, trade, ignore each other? The archaeological record offers tantalizing hints, but no complete answers. The mystery deepens the more we learn. We know they interbred. The DNA evidence is unambiguous. Every person of non-African descent carries Neanderthal genes. The mixing was real and it was widespread. These were not isolated incidents. The percentage varies by individual. Most people carry between 1 and 4% Neanderthal DNA, but the specific genes differ from person to person collectively. About 40% of the Neanderthal genome survives scattered across modern humans. The interbreeding had to happen multiple times over thousands of years. The Neanderthal DNA in modern Europeans differs slightly from the Neanderthal DNA in modern Asians. Different mixing events, different lineages, different stories. Interestingly, African populations have little to no Neanderthal DNA. The mixing happened after modern humans left Africa, but before they spread across the globe, Europe and the Near East were the meeting grounds. What did these encounters look like? We cannot know for certain, but we can imagine a hunting party from one group encountering a family from the other. Curiosity, caution, eventually something more. Some of these meetings must have been violent. Competition for resources was intense during the Ice Age. Large game was essential for survival, and both species hunted the same animals. Two apex predators in the same ecosystem rarely coexist peacefully. When mammoth herds moved or declined, competition would have intensified. The stakes were survival itself, but violence alone cannot explain the genetic mixing. You do not pass your genes to another population through warfare alone. There had to be something else. Relationships, families, children raised by both kinds of humans. Some researchers have suggested that most interbreeding may have occurred early in the contact period, when the two species first met. Perhaps novelty or curiosity drove those initial encounters. Others argue that interbreeding continued throughout the coexistence period. The genetic evidence is consistent with multiple independent mixing events spread across thousands of years and different geographical regions. The children of these unions would have been viable, fertile, able to have children of their own. This means the two species were genetically close enough that reproduction was successful across the divide. Modern studies of the genome show which Neanderthal genes survived in us and which did not. Some were beneficial and spread through the population. Others were harmful and were gradually eliminated by natural selection. Neanderthal genes that helped us survive include those affecting immune response, skin and hair characteristics, and adaptation to cold climates. We inherited useful traits from our cousins, but some Neanderthal genes caused problems. Researchers have found correlations with depression, blood clotting disorders, and certain autoimmune conditions. The inheritance was not all positive. One particularly interesting finding involves fertility. Neanderthal genes are largely absent from certain regions of the human genome, particularly those involved in male fertility. This suggests that hybrid males may have had reduced fertility. The pattern is similar to what we see in other hybrid species. Male ligers and mules are often sterile or subfertile, while females remain fertile. The same dynamic may have affected human Neanderthal hybrids. This matters because it suggests the two species were right at the edge of reproductive compatibility, close enough to produce children, but far enough apart that those children faced biological challenges. The archaeological sites from this period tell their own stories. In some places, we find Neanderthal tools and modern human tools in the same layers. The two groups clearly used the same locations. Whether they used them at the same time is harder to determine. Perhaps one group moved in after the other left. Perhaps they alternated seasonally, or perhaps they sometimes shared space. At other sites, we see what looks like cultural exchange. Neanderthals in some regions began making ornaments and tools in styles similar to those of modern humans. Were they learning from their new neighbors? The timing is suggestive. These innovations appear after modern humans arrived, not before. Contact seems to have sparked change. Ideas crossed the species boundary just as genes did, or were modern humans learning from Neanderthals? Some researchers argue that certain innovations traditionally attributed to our species may have originated with our cousins. The flow of ideas could have gone both ways. The Ch. Phaetopuronian culture, found in France and Spain, shows a blend of Neanderthal and modern human characteristics. Who made these tools? Neanderthals adopting new techniques, hybrids. The question remains open. Recent analysis of teeth found with Ch. Phaetopuronian tools shows they belonged to Neanderthals. But the tools themselves look almost modern human. Cultural transfer was happening in real time. Language may have been exchanged as well. If both species had language, and the evidence suggests they did, then contact would have enabled communication. Vocabulary might have been shared. Some linguists have speculated that certain sounds or words might have passed between species. We cannot test this directly, but the interbreeding proves extended contact occurred. Where there is contact, there is communication. We will never know what words, if any, passed between them. But the fact of interbreeding suggests some level of mutual understanding, You do not form families with beings you cannot communicate with at all. The climate during this period was brutal. Ice Age Europe was far colder than today. Glaciers covered Scandinavia and reached deep into the continent. The ice sheet over Britain was up to a mile thick. Tundra and steppe replaced the forests that had once dominated. Mammoth, woolly rhinoceros, and reindeer roamed the grasslands. It was a harsh world, but Neanderthals had thrived in it for hundreds of thousands of years. Neanderthals were physically adapted to this cold. Their bodies were stocky and powerful, designed to conserve heat, shorter limbs, barrel chests, large noses to warm the air they breathed. Their limb proportions follow what biologists call Allen's rule. Animals in cold climates have shorter extremities to reduce heat loss. Neanderthals had shorter forearms and lower legs than modern humans. Their large nasal passages served a purpose. Cold, dry air damages lung tissue. By warming and humidifying air before it reached the lungs, Neanderthal noses provided protection against the harsh atmosphere. Modern humans were built for African heat. Long limbs, lean bodies, efficient at shedding warmth. We were poorly designed for the Ice Age climate we had wandered into. Adaptation was necessary. We had to rely on technology, better clothing, better shelters, better fire management. Where Neanderthals had bodies built for cold, we had culture built for flexibility. The Neanderthal genes we inherited may have helped. Cold adaptation, immune responses to unfamiliar diseases, skin and hair that function better in northern climates. Our cousins gave us tools for survival, but if Neanderthals were so well adapted, why did they disappear? If they had bigger brains, made tools, created art, and had survived 300,000 years of climate swings, why are they gone? This is the central mystery. The disappearance happened gradually over several thousand years. Around 35,000 years ago, Neanderthal populations began declining. By 30,000 years ago, they were rare. By 28,000 years ago, they were gone. The last Neanderthals seem to have survived in refugia. Isolated pockets of habitable land, Gibraltar, parts of Croatia, remote corners of Iberia, clinging to existence while the world changed around them. Multiple theories attempt to explain their extinction. None is fully satisfactory. The truth probably involves a combination of factors, each contributing to the decline. Theory 1 is direct competition. Modern humans may have simply outcompeted Neanderthals for resources. We were more efficient hunters. We had larger social networks. We could extract more from the environment. Modern human hunting technology was different. We threw our spears rather than thrusting them. This allowed us to kill from a distance, reducing the risk of injury. Hunting became safer and more efficient. We also had dogs. The exact timing of dog domestication is debated, but wolves were becoming dogs somewhere during this period. Hunting with wolves changes everything. You can track prey more easily. You can drive animals toward waiting hunters. Modern humans lived in larger groups. Archaeological evidence suggests our ancestors formed communities of over 150 individuals, while Neanderthal groups rarely exceeded 50. Numbers matter in competition. The difference may have been about mobility. Modern humans seem to have maintained social connections over much larger distances. When resources failed locally, we could move to areas where we knew people who would help us. Larger groups mean more specialization, more innovation, more resilience against disasters. If a hunting party from a large group fails, others can share food. A small group has no such buffer. We also seem to have been more flexible in diet. When large game was scarce, modern humans shifted to fish, birds, and small mammals. Neanderthals appear to have been more dependent on large game hunting. This flexibility became crucial during climate fluctuations. When mammoths moved or died out locally, modern humans found alternatives. Neanderthals, specialized for big game hunting, may have struggled. Theory 2 is indirect competition through disease. Modern humans coming from Africa brought pathogens that Neanderthals had never encountered. Their immune systems had no defenses against our germs. We have seen this pattern repeat throughout history. When populations that have been isolated for millennia suddenly meet, disease transfer is devastating. Smallpox killed 90% of some Native American populations. Modern humans had been exposed to more pathogens in Africa. Larger populations meant more opportunities for diseases to evolve and spread. We were disease reservoirs, carrying germs we had learned to survive. The genetic evidence supports this theory. Neanderthal genes related to immune function appear frequently in modern humans. We may have inherited disease resistance from them, suggesting exposure was mutual. The exchange may have gone both ways. We gave them new diseases. They gave us immune genes to fight old ones. Both populations were shaped by the encounter. Theory 3 focuses on climate. The period of coexistence included dramatic climate swings. Temperatures fluctuated. Glaciers advanced and retreated. Ecosystems transformed repeatedly. Around 32,000 years ago, a particularly severe cold period began. The Heinrich Event 4 brought extreme conditions to Europe. Temperatures dropped. Ice sheets expanded. Habitable land shrank. Neanderthals had survived climate changes before, but perhaps not while also competing with modern humans. Perhaps not while also fighting off new diseases. The combination of pressures may have been too much. Modern humans retreated during this period too. Some areas of Europe were abandoned by both species. But modern humans had options. They had connections to populations in warmer regions who could take them in. Neanderthals were European specialists. They had evolved there for hundreds of thousands of years. When Europe became uninhabitable, they had nowhere else to go. No connections to populations in Africa or Asia. Theory 4 suggests reproductive disadvantage. If hybrid males were less fertile, as the genetic evidence suggests, then Neanderthal genes would have been slowly diluted with each generation of interbreeding. Imagine a small Neanderthal population that occasionally interbreeds with a larger modern human population. Even without any violence, the Neanderthal genes would be overwhelmed over generations, absorbed rather than destroyed. In this view, Neanderthals did not go extinct. They were assimilated. Their genes live on in us. Their disappearance as a distinct population was really a merger, not an ending. The truth probably includes elements of all these theories. Competition, disease, climate stress, and reproductive dynamics all played roles. Extinction is rarely simple. It is usually an accumulation of pressures. What we can say is that the disappearance was not instantaneous. For thousands of years, both species continued to exist. The overlap was real and prolonged. They knew about each other. Think about what that knowledge must have meant. Our ancestors knew there were others like them, but not quite like them. People who looked different, spoke differently, made slightly different tools. Did they see Neanderthals as fellow humans, as dangerous animals, as something in between? The interbreeding suggests at least some individuals crossed whatever conceptual boundaries existed between the groups. Some of those relationships must have been consensual. Partnerships formed, children raised, families created. The genetic evidence requires this. But we cannot know how common such relationships were. Other encounters may have been violent. Rape is a feature of human conflict throughout history. We cannot assume that all interbreeding was peaceful. The truth was probably varied and complicated. The genetic evidence itself cannot tell us which encounters were consensual and which were not. It only tells us that reproduction occurred. The human stories behind the genes remain forever hidden. What we can say is that both kinds of encounters probably happened. Human nature includes the capacity for both love and violence. Our prehistoric ancestors were no different in that regard. The children of these unions faced unique challenges. Where did they belong, with their mother's group or their father's? Were they accepted by either, by both, by neither? Some hybrid individuals clearly survived and thrived. Their genes are in us today, but others may have struggled. Being different is rarely easy in any time or place. We know that some hybrids had children of their own. The Neanderthal genes in modern humans had to pass through multiple generations to reach us. Those hybrids found mates and continued their lineages. But the pattern of Neanderthal genes in our genome tells a more complex story. Some regions show evidence of selection against Neanderthal variants. Certain combinations may have caused problems. The genes that remain are the survivors. They pass the test of natural selection. Whatever disadvantages they might have carried were outweighed by their benefits, or at least were not harmful enough to be eliminated. The last Neanderthals must have known they were disappearing, their range shrinking, their numbers declining. Fewer children born each generation, the old camps abandoned one by one. The young ones may not have remembered when the land was full, when other groups lived in the next valley, when gatherings brought dozens of families together. For them, emptiness was normal. Did they understand what was happening? Did they have concepts for extinction, for the end of their kind? We cannot know. But they were intelligent beings facing an existential crisis. Perhaps they told stories about the old times, when the hunting was good, when there were enough people for proper ceremonies, when the future seemed secure. All peoples have such stories. The very last Neanderthals probably lived in Gibraltar, in caves overlooking the Mediterranean. The climate there was mild even during the Ice Age. They held on longer than anywhere else. The Rock of Gibraltar is limestone. riddled with caves that have sheltered humans for tens of thousands of years. Neanderthals knew these caves intimately. Generation after generation called them home. Gorham's Cave contains evidence of Neanderthal occupation until around 28,000 years ago. They lived there for at least 20,000 years. The deposit layers tell of continuous use across millennia. The Neanderthals of Gibraltar hunted seals and gathered shellfish. They were adapting, becoming more flexible in their diet as circumstances demanded. But it was not enough. Among the last things they left behind was an engraved pattern on the cave wall. Abstract lines cut into stone, a cross, hatch design that required multiple careful strokes to create. Was this art? A symbol? A message? We will never know what it meant to them. But someone took the time to make it, carving carefully into rock that would preserve their work for tens of thousands of years. And then they were gone. The last Neanderthal died, and a 300,000-year chapter of human history closed forever. But their genes lived on. Their legacy endured in the species that replaced them. We carry them with us still. Every person of non-African descent is part Neanderthal. We are the hybrid species, the product of that ancient encounter between two kinds of humans. The genes they gave us are not trivial. They affect our immune systems, our skin, our hair, our propensity for certain diseases. Neanderthals shaped what we are at the molecular level. Your keratin proteins, the stuff of hair and nails, may include Neanderthal versions. Some variants are associated with straight hair, others with hair color. The Neanderthal in you may be visible in your appearance. Some Neanderthal genes may have helped us survive the Ice Age, cold adaptation, different fat metabolism, vitamin D synthesis in low-light conditions. Our cousins gave us what we needed to live in their world. Vitamin D is crucial. Modern humans evolved in tropical Africa, where sunlight is abundant. In Northern Europe, with its long, dark winters, we needed new ways to produce this essential nutrient. Neanderthals had already solved this problem. They had lived in Europe for hundreds of thousands of years. Their genetic adaptations for northern light conditions became our inheritance. Recent research suggests that Neanderthal genes may also affect behavior. Variants associated with pain sensitivity, circadian rhythms, and even mood have been traced to our ancient relatives. This does not mean Neanderthals determine our behavior, but it means they contributed to the raw material from which our behaviors emerge. They are part of our psychological inheritance. Some research links Neanderthal gene variants to depression risk. Other studies find connections to immune disorders. The relationships are complex and still being untangled by scientists. The story complicates further when we consider other ancient humans. Neanderthals were not the only cousins we met. There were Denisovans in Asia and possibly other groups we have not yet identified. The Denisovans are known almost entirely from their DNA. A finger bone, a few teeth, and fragments from a single cave in Siberia. Yet their genetic legacy survives in modern populations, especially in Melanesia. The cave sits in the Altai Mountains, where Siberia meets Mongolia and China. It was named after a hermit who lived there in the 18th century. He had no idea what the cave contained. The finger bone was tiny. It came from a young girl who died perhaps 50,000 years ago. But the DNA inside was remarkably well preserved by the cold. When scientists sequenced it, they found something unexpected. The DNA was neither modern human nor Neanderthal. It belonged to a previously unknown human species, an entire branch of our family tree, discovered not from fossils, but from molecules. Melanesian populations carry more Denisovan DNA than any other modern group. As much as 5% of their genome may come from these mysterious cousins. The mixing was substantial. How did Denisovan genes get to Melanesia? The Denisovans lived in Siberia, far from the Pacific Islands. The answer is that they must have been more widespread than a single cave suggests. They once roamed across Asia. Modern humans moving through Asia would have encountered them, mixed with them, carried their genes onward to Australia and the Pacific Islands. The Denisovans left their mark on populations they never directly met. The Denisovan genes in modern humans include some affecting immune function, as with Neanderthals. But they also include genes related to adaptation to high altitude. Tibetan populations carry a Denisovan gene that helps them survive at elevation. The gene affects how the body responds to low oxygen. It is found in almost 90% of Tibetans, but is rare in lowland populations. Without this Denisovan inheritance, high-altitude life would be much harder. There may have been other cousin species we have not discovered yet. Ghost populations detected only through genetic traces in modern humans. Shadows of extinct peoples whose bones we may never find. What emerges is a picture far more complex than the simple story of human evolution we once told. It was not a linear progression from primitive to advanced. It was a web of connections, mixing, and exchange. Multiple human species coexisted for tens of thousands of years. They met, they mated, they exchanged genes and perhaps ideas. The modern human genome is a composite, a mixture of contributions from multiple sources. This challenges our sense of human uniqueness. We are not a pure species, distinct from all others. We are a hybrid, carrying the genetic legacy of beings we once considered entirely separate from us. It also raises questions about what it means to be human. If Neanderthals could interbreed with us, produce fertile offspring, make art and tools, were they not human too? Where do we draw the line? Some scientists argue that Neanderthals should be reclassified as a subspecies of Homo sapiens rather than a separate species. The reproductive compatibility and genetic mixing support this view. The biological species concept defines species as groups that can interbreed and produce fertile offspring. By this standard, Neanderthals and modern humans were the same species, or close enough that the distinction blurs. Others maintain that the physical and cultural differences justify separate species status. Neanderthals were distinct in many ways, even if they could produce children with our ancestors. The debate is more than academic. It shapes how we think about our past, our identity, and our relationship with other beings. It asks what characteristics make someone part of our family. If Neanderthals were human enough to be our ancestors, what about other hominins? What about the Denisovans? What about species we have not discovered yet? the boundaries of humanity become fuzzy. 35,000 years ago, that question had practical urgency. When our ancestors met Neanderthals, they had to decide how to respond. Were these strangers, enemies, potential partners, fellow travelers? The answer they gave, collectively over thousands of years, was complicated. Some violence, some exchange, some interbreeding, some avoidance, the full range of human responses to human difference. We like to think we would have been tolerant, that we would have recognized Neanderthals as people deserving respect. But human history offers little support for such optimism. Even within our own species, we have struggled to see others as fully human. Wars, genocide, slavery, all rest on denying the humanity of people who look or act differently. Our record is not good. Everywhere populations have met, conflict has followed. Competition for resources, fear of the different, desire for what others have. The dynamics that may have doomed the Neanderthals are still with us. Yet exchange has also happened. Trade, intermarriage, cultural learning, the same forces that spread Neanderthal genes through our population continue to connect human groups today. We are a species that both destroys and absorbs. We eliminate and incorporate. We fight and we mate. The Neanderthal story captures both sides of our nature in prehistoric clarity. The Neanderthal story is a mirror. It shows us both our capacity for destruction and our capacity for connection. We absorb them, but we also carry them forward through time. Every time you look in the mirror, you see their legacy. In the shape of your face, perhaps, in the color of your skin, in immune cells that fight infection the way their immune cells did. You are the result of that ancient encounter. The living proof that when two kinds of humans met, they did not only fight, they also joined. They also created something new. The children they had together, against whatever odds, in whatever circumstances, survived, thrived, spread across the planet, became you. Eventually, through an unbroken chain of reproduction spanning 35,000 years, you are the great-great-grandchild, 1,000 generations removed, of someone who loved or was taken by someone from a different kind of human. That fact lives in your cells. Every cell in your body carries the record. The mitochondria that power your muscles, the proteins that build your tissues, the instructions written in DNA that make you who you are. Neanderthals contributed to all of it. If you have drifted off by now, that is perfect. The Neanderthals have been gone for 28,000 years. This mystery will still be here when you wake up. And if you are still awake, consider what you carry. Not just memories and experiences, but genetic information from people who lived in Ice Age caves, hunted mammoths, made art on stone walls. The shape of your face may owe something to them. The way your immune system responds to infection, the texture of your hair, the shade of your skin, all potentially influenced by ancestors from another species. They did not know they would survive in this way, that their genes would spread through a species that would eventually number 8 billion, that their descendants would walk on the moon and split the atom. Everything they dreamed, if they dreamed, was smaller than this. A successful hunt, a safe cave, children who survived to adulthood. They had no concept of the future they were creating. Yet here you are. Part them, part your other ancestors, part something entirely new, the latest chapter in an ongoing story. 35,000 years ago, two kinds of humans lived together in the forests and valleys of Europe. They competed, they fought, they mated, they exchanged ideas and genes. The encounters were varied, sometimes violent, sometimes tender, sometimes transactional, sometimes loving. The full range of human relationship played out across millennia between beings who were almost but not quite the same. One species disappeared. One species spread across the globe. But the story is not one of simple replacement. It is a story of merger, of inheritance, of continuity through transformation. The Neanderthals are not entirely gone. They survive in you. In the stranger on the street, in every person whose ancestors passed through Europe or Asia on their way to where they are now. Subscribe if you want to explore more mysteries. Like this one, the origin of language, the meaning of dreams, the fate of other human species. Questions that reveal who we are. For now, rest well. Tomorrow you will wake with Neanderthal genes still working inside you, regulating your immune system, affecting your skin and hair, shaping who you are in ways you will never notice. They live on in the lives we live, in children yet to be born, in futures we cannot imagine. The Neanderthals survived their extinction by becoming part of us. 35,000 years ago, humans and Neanderthals lived together, and in a sense, they still do. Good night.